Professor Dave and Chegg here. We already know how to use IUPAC nomenclature rules to name linear compounds, but many organic molecules are cyclic, meaning they contain one or more rings. How do we name these? Let's get a better understanding of this now.
Again, cyclic compounds are just what they sound like. There are no endpoints to the molecule. They just loop back around on themselves. These can have as few as 3 carbons, and there is no firm upper limit to the size of the ring, though we will rarely see anything bigger than 10 or so. 5-membered and 6-membered rings are ubiquitous in nature, so we will be dealing with these quite a bit. There isn't too much that changes in terms of naming these molecules, but there are a few new rules to learn, so let's make sure to go over them now. First, we will need to use the prefix cyclo when naming cyclic compounds. For simple cycloalkanes, we just put that prefix in front and we are all set. That's how we get cyclopropane, cyclobutane, cyclopentane, cyclohexane, and so forth. Now let's talk about substituents. Let's say we have just one substituent, like this methyl group. In this simple case, we don't even need to specify where the methyl group is, because all the carbons are the same, so no matter where the methyl group is, it's the same molecule. This is therefore just methyl cyclohexane. However, bear in mind that if the substituent has more carbons than the ring, then it is actually the ring that is the substituent on a longer linear molecule. So this would not be butyl cyclopropane. It's actually 1-cyclopropyl butane. Things get a bit trickier when we have multiple substituents. Let's go back to methyl cyclohexane and place another methyl group over here. Now we do need to report the positions of the methyl groups because there are several possible molecules involving 2 methyl groups on a cyclohexane. How shall we number this ring? Well, since there are no endpoints, we can start numbering at any carbon we want. And as you can guess, we will number in such a way so as to give the substituents occurring at the lowest set of locants possible. This means that the carbon that bears 1 methyl will be carbon 1, and we will number in the direction that puts the other methyl on carbon 3, rather than going the other way, which would put it on carbon 5. That's because 1,3 is a lower set of locants than 1,5. So this will be 1,3-dimethyl cyclohexane. Let's put one more methyl group on there, on what currently appears to be carbon 4. Now we have to be careful. We could be tempted to call this 1,3,4-trimethyl cyclohexane, but that actually is not the lowest set of locants possible. If we start numbering down here and go the other way around the ring, we can get 1,2,4-trimethyl cyclohexane, and since that is a lower set of locants, that is indeed the name of this molecule. This approach will work for any set of alkyl or halo substituents, and we will list the substituents in alphabetical order just as we do for linear molecules. So this is 1-ethyl 2-methyl cyclopentane, with the ethyl specifically on carbon 1 because it comes first alphabetically. This is 1-bromo 2-methyl cyclobutane for the same reason. And the same logic applies for tri-substituted molecules like these.
With that, we should have a solid understanding of how to name any cyclic hydrocarbon with alkyl or halo substituents. Professor Dave for Chegg. See you next time.